What you are seeing right now is the real behavior of 3I Atlas, and it is happening at this very moment. A giant interstellar object is rushing into our solar system, but instead of forming a normal tail that points away from the sun, it has created a reverse tail that stretches directly toward the light. And even stranger, the narrow jets coming from it are so sharp that some scientists believe they may not be natural at all, but signs of a probe releasing smaller devices. If this is true, we are not just watching a comet. We are watching a rule of nature break in front of us. So what is 3I Atlas really? And why does it behave as if it was designed? Stay until the end of the video to understand why both scientists and skywatchers cannot stop talking about 3I Atlas. Most comets follow one simple rule, and it is the rule that holds the whole system together, because their tails always point away from the sun. The heat and radiation push dust and gas outward, so the tail stretches in the opposite direction no matter how the comet turns or bends. This rule is so reliable that astronomers use it to track motion, measure rotation, and confirm structure. Nothing in the sky has ever broken this rule in a dramatic way until 3I Atlas appeared. At first, the object looked like a normal interstellar visitor, but the early images showed something that immediately broke the pattern. Instead of forming a tail that streamed away from the sunlight, 3I Atlas produced a long streak of brightness that pointed directly toward the sun. This unusual feature is known as an anti-tail, yet the version seen on 3I Atlas is far larger and more defined than anything ever recorded. Earlier comets like Rand-Roland or Encke showed faint, short anti-tails formed by dust trapped along their orbits. Atlas displayed something completely different, since its line of light stretched almost 1 million kilometers toward the sun and nearly 3 million kilometers in the opposite direction. From Earth, the object looked like it had huge wings, even though its core is only a few kilometers wide. Scientists struggled to understand how a nucleus that small could create structures that large without breaking apart. The anti-tail stayed sharp instead of softening the way dust normally does when the solar wind scatters it. This made astronomers question whether the feature was drifting material or something more directed and controlled. Observatories across Chile, Hawaii, Spain, and South Africa then detected another strange detail because 3I Atlas was releasing multiple narrow jets at the same time. There were 7 in total, and each one pointed in a different direction, which created a pattern that looked more geometric than natural. Some of the jets moved toward the sun, while others pushed outward or sideways, and none of them spread out like the gas streams of typical comets. The structured shape made the object look as if it was following an internal rhythm instead of reacting passively to solar forces. The changes also happened unusually fast, because 3I Atlas showed a normal comet tail one moment, then lost it, then suddenly produced the anti-tail, and then formed thin light streaks around its body. These shifts took place within a few days, which is much faster than any natural dust system should evolve. Even when a powerful solar plasma burst swept across the region, the anti-tail did not twist or break, and this shocked observers because weaker comets nearby showed visible distortion. Some amateur groups also noticed that the anti-tail did not show the polarization pattern expected from dust clouds, and its light stayed even across the entire length. This created a new problem because the amount of material needed to produce such a focused line would require a surface far larger than 3I Atlas actually has. Hubble data placed the core at only a few kilometers wide, so the anti-tail made experts consider 2 possible explanations. One idea was that 3I Atlas had broken into multiple pieces and exposed new surfaces that produced more dust. Another idea was that something was increasing the energy of the jets in a way that made them act like directed streams. The second idea sounded unusual, Yet many researchers kept it on the table because Atlas continued showing behavior that did not match any natural model. The anti-tail remained bright and narrow, and the jets acted with a level of structure never seen in comets. The more images arrived, the more 3I Atlas looked like an object performing its own process rather than drifting through space. This leads to a larger question that pushes the mystery even further. If the anti-tail is not acting like normal dust, then what exactly is producing such a powerful and focused stream? And does this mean 3I Atlas is doing more than simply passing through the solar system? The probe theory begins with a simple question that scientists ask whenever an object behaves in a way that does not match nature. Is this only an extreme natural event, or could it be something designed for a purpose? This question grew stronger when 3I Atlas started showing changes that no normal comet should produce. Some researchers looked at the sudden jets, the strange growth in surface area, and the controlled behavior, and they asked if Atlas could be releasing smaller units while continuing its path. This idea leads to the concept of a parent craft, a larger body that hides several small objects inside and only deploys them at the right time. The core of the probe theory is simple, because it imagines Atlas as a carrier that drops tiny devices while moving past the sun. A natural object breaks apart by accident when it heats up, but a constructed object could use that same stress to trigger a planned operation. This is why some scientists looked closely at the unusual changes in brightness around 3I Atlas, because they resemble a split but do not create the debris field expected from a broken comet. Gas and dust models showed that 3I Atlas seemed to gain surface area much faster than physics can explain, and this only works if the nucleus divided into many parts. A natural breakup would leave scattered fragments, but a controlled release could place the pieces in a pattern too neat to detect from Earth. This creates the idea that the fragmentation might not be a failure, but the beginning of deployment. The timing of these changes makes the theory even stronger because everything happened near perihelion. When 3I Atlas moved behind the Sun, Earth became blind for several days, and most telescopes could not track its shape or motion. This blind zone is important because any object wanting to adjust its path or release small probes would choose a moment when no one was watching clearly. Even a dramatic event could remain hidden until Atlas reappeared after crossing the Sun's far side. The jets on 3I Atlas add another strange detail to the story because they are narrow, bright, and steady. Natural vents spray out in wide clouds, but the jets on 3I Atlas look more like controlled thrust coming from specific points. Some jets point toward the Sun, which almost never happens in normal comets, and this makes people wonder if the jets stabilize the body rather than push it away. The comparison between 3I Atlas and the two earlier interstellar objects gives the theory even more weight. Oumuamua showed unpredictable rotation, strange acceleration, and brightness that changed sharply, and these features made many scientists think it acted like a guided object. Borisov behaved exactly like a natural comet because it released gas and dust in familiar ways and broke down as expected. 3I Atlas looks far closer to Oumuamua than to Borisov because it changes shape quickly, moves with steady control, and produces jets that follow their own pattern. The strange expansion, the possible hidden fragments, the precise timing at perihelion, and the sharp jets all push the discussion toward missions rather than accidents. This leads to the next question, and it is one that creates real tension. If 3I Atlas might be releasing smaller units, then what are those objects, and what could they do once they leave the parent body? And that question becomes even more important when we look at what happened at perihelion, where 3I Atlas broke rules even more dramatically. Perihelion is the moment when an object comes closest to the Sun, and this stage normally makes comets behave in predictable ways. When 3I Atlas reached this point, it started breaking rules that scientists thought were universal. As 3I Atlas approached the Sun, its colors began shifting in rapid cycles that no natural comet had ever shown. Instead of staying white or turning slightly blue, Atlas flashed green, red, and bright white in a repeating sequence. These changes made astronomers wonder if the surface was reacting to sunlight rather than simply melting under heat. The brightness pattern added another layer of mystery, because Atlas became more reflective as it moved into stronger radiation. Most comets grow dimmer or burst apart during this stage, yet 3I Atlas reflected light with a smooth and steady curve. There were no chaotic flickers that usually appear in dust clouds, and this stable glow suggested a surface that behaved like a single structure. The speed of 3I Atlas created even more questions, because it became the fastest interstellar object ever recorded, reaching more than 130,000 miles per hour. This velocity placed it on a hyperbolic orbit, which confirmed that it did not come from our solar system and would not remain bound to the Sun. Hyperbolic objects usually show unstable motion, yet 3I Atlas moved with surprising control, as if guided by a stable interior. Telescopes then looked closely at the region of light surrounding the object, expecting to see a cloud of dust that changed shape as it heated up. Instead, they saw a smooth halo with clear edges and no signs of turbulence. The glow stayed steady across multiple images from Chile, Spain, and Hawaii, which made Atlas look more like a solid body than a loose mix of ice. Some scientists pointed out that uniform brightness is extremely rare in comets because natural objects usually break into rough and uneven fragments when they face high heat. The biggest surprise came from the chemical readings, and these readings turned the mystery into something far more serious. Spectral data showed a massive envelope of carbon dioxide stretching more than 217,000 miles around Atlas, which is wider than Jupiter. Inside this cloud were traces of hydrogen cyanide, a compound that appears only under special chemical conditions. Researchers expected to find water or carbon monoxide, but instead they found this unusual mix. The metallic signature shocked astronomers even more. V carried extremely high levels of nickel and almost no iron, which is the opposite of what is normally seen in natural interstellar bodies. Some experts quietly called this pattern an industrial signature because the ratio looked closer to refined material than raw space rock. Together, these clues suggested that 3I Atlas might have an internal structure unlike anything seen in ordinary comets. The unusual orbit, the controlled brightness, and the chemical mix created a picture that no standard model could explain. These anomalies left scientists with a growing question. If Atlas could show this level of stability at the most dangerous point of its journey, then how would it react when the Sun sent a powerful burst of plasma straight into its path? That question takes us into the next part, where Atlas faced one of the strongest solar events of the year and responded in a way that stunned everyone watching. The moment Atlas moved into the region where solar storms reach their highest power, many scientists expected the object to react like any fragile body that faces intense radiation. The Sun released one of the strongest plasma eruptions of the year, and this massive blast came from the active zone AR4274, which had already produced several dangerous events. This coronal mass ejection carried the force of millions of nuclear weapons, and it traveled fast enough to disturb magnetic fields across huge areas of space. The blast hit Earth soon after, and radio networks across 5 continents reported sudden blackouts that lasted from minutes to hours depending on the region. Several aircraft experienced strange behavior in their navigation tools, and a number of satellites switched into safe mode to protect their systems from the rising radiation. The United States issued a geomagnetic storm alert for 11 states because the event reached levels G4 and G5, which are strong enough to damage transformers and disrupt electrical grids. These effects showed how powerful the eruption truly was, and they proved that any object in its path would face extreme stress. Astronomers believed that 3I Atlas would react like a natural comet, because most cometary bodies lose mass or spin out of control when hit by solar plasma. A normal comet would show a sudden rise in brightness as heat strips off the surface. 3I Atlas did not do that, and its brightness remained steady, even during the peak of the storm. Observatories that tracked the object in real time found that 3I Atlas stayed on its predicted course, even though the blast could push dust clouds thousands of kilometers. The object held its direction with almost no shift, and its rotation did not change in any of the new images. Nothing suggested damage or weakening, and this shocked observers who expected to see a cloud of fragments behind it. Some scientists compared the behavior to a ship cutting through violent waves, because 3I Atlas kept moving forward in a way that looked controlled. The stability raised new questions about the internal layout of the object, since something soft or loosely built would have cracked under such pressure. Infrared readings also showed no sharp temperature jump, which meant the surface might be spreading heat evenly instead of melting. This sparked discussions about whether 3I Atlas had a layered interior or a shell capable of handling thermal stress far better than ice or rock. The lack of visible reaction to such a violent event is now one of the strongest reasons why scientists are rethinking what Atlas actually is. If it were just a comet, the blast should have left a clear mark, yet every sign shows that Atlas behaved like a dense and solid body, able to resist heat and force. The survival of 3I Atlas has turned it into one of the most puzzling visitors ever recorded, and it forces researchers to question what they assumed about its structure. Some experts think 3I Atlas might have a heavier core, while others believe the gas readings and strange jets suggest something more advanced than a simple natural object. The CME event did not bring answers, and instead it opened the door to a larger mystery about how 3I Atlas works and why it stayed untouched. This leads directly to the next question, which appeared only days later when Atlas began losing mass for reasons no one could explain. If 3I Atlas showed perfect stability during the solar strike, then why did it suddenly start shedding material afterward, and what exactly caused that change? Astronomers grew even more confused when 3I Atlas began losing mass soon after moving past its closest point to the Sun. The change was clear because the coma around the object started shrinking in some areas while stretching out in others, and this uneven pattern suggested that something major had taken place inside the body. Scientists who study natural comets were the first to offer an explanation. They said that extreme heating can cause a comet to crack or fall apart, even if the damage cannot be seen clearly from far away. In a normal breakup, the object should leave behind a long trail of fragments that drift through space for many days. Observatories searched for that trail, but they could not confirm any stable cloud of debris. The absence of fragments surprised many researchers because almost every comet that loses mass this fast leaves behind something that instruments can detect. This missing debris created a new idea that the mass loss might not be a simple natural event. Another group proposed that 3I Atlas could be releasing material on purpose, and they said the loss looked too smooth to come from an accident. If the object had a power system or a mechanical design, then the drop in mass might come from burned fuel, stressed parts, or even the separation of a module. This view gained support because the change did not create the chaotic spray that usually appears during natural fragmentation. Several astronomers also noticed that the brightness around 3I Atlas shifted in an organized way, almost as if the shape of the object had changed. NASA reacted with caution and said that more data was needed before anyone could reach a final conclusion. Their careful tone made the public even more curious because it avoided discussing the most unusual details behind the mass loss. The scientific world soon divided into two major sides. The first group believed 3I Atlas remained a comet and argued that every strange event could still be explained by heat, gas, and normal chemistry. They pointed to new radio readings from the Meerkat Array in South Africa, which detected hydroxyl molecules that appear when sunlight breaks water apart. This finding suggested that 3I Atlas still carried water inside it, and the breakdown matched the expected behavior of a comet moving through the inner solar system. The second group rejected this view and said the hydroxyl detection did not explain why the mass loss followed a smooth curve or why no debris cloud was visible. They also reminded others that 3I Atlas showed narrow jets earlier in its journey, which hinted at activity that did not match natural physics. Some researchers said the loss might come from an internal failure, while others suggested that 3I Atlas could be going through a planned stage that instruments could not detect properly from its current distance. Avi Loeb's comments added more pressure to the debate when he said that humans have already built machines that travel far beyond Earth and that other civilizations could do the same. His words appeared in podcasts and interviews because they made people think about how technology can hide inside patterns that look natural. Every new observation increased the disagreement because no explanation matched all the available data. Some teams focused on the possibility that an internal engine had overheated, while others studied the idea that Atlas was preparing for a new stage after passing the Sun. Even with all these differences, scientists agreed on one important point. They needed closer images to decide whether Atlas had exploded or simply changed its structure. NASA confirmed that December 19th would be the best moment to find answers, because 3I Atlas would move close enough to show signs of cracks or separate parts. Many observatories are preparing for that day because they hope the new distance will finally solve the mystery behind the mass loss. But this raises a bigger question that leads directly into what comes next. If so many scientists are ready to observe 3I Atlas, then why did NASA stop sharing new information at the exact moment the object became even stranger? The silence began at the moment when the world expected the most information, because NASA suddenly stopped all public updates while Atlas entered its most important stage. The United States government shutdown on October 1st forced many agencies to pause communication, and NASA was one of the first to freeze its public channels. The main website stopped posting new data, and accounts that usually updated daily went completely quiet without warning. Only essential missions like the International Space Station continued to receive support, which meant deep space observations were no longer shared in real time. Soon after, amateur researchers noticed that raw images from the James Webb Space Telescope and the Mars Reconnaissance Orbiter were missing from the public archive. These images should have shown 3I Atlas during its approach, yet some files were marked unavailable and others disappeared without explanation. This unusual gap immediately raised questions about why such important data was withheld during a major scientific moment. NASA also did not follow up on its previous report about the mass loss anomaly, and this long pause made many people wonder what the agency had discovered. Scientists offered two main explanations to avoid assuming anything dramatic. The first idea was that NASA wanted to wait for verified results before releasing anything new, because wrong information could cause confusion during an intense scientific debate. The second idea was that the agency wanted to avoid unnecessary panic, especially since opinions between Avi Loeb and traditional astronomers had already divided the public. While NASA stayed silent, international observatories filled the empty space with rapid updates. The ALMA array in Chile released new images showing clear gas jets and changes in brightness that matched amateur reports. Meerkat in South Africa published radio results that detected hydroxyl signals, which helped support the comet interpretation. Subaru in Hawaii shared high-resolution photos showing Atlas brighter than predictions, and these unexpected results spread quickly across the internet. The Telescopio Nazionale Galileo in Spain added long-exposure images revealing repeating light variations, and this made the mystery even deeper. With each new release, the world began relying more on these observatories than on NASA, which had once been the main source of deep space information. At the same time, the global amateur community became a powerful force that kept the story alive. Thousands of observers using Zooniverse and Unistellar uploaded their own photos, creating a wide network of night sky reports. Some images showed Atlas shining much brighter than expected, and others revealed a strange rhythmic pattern that repeated across several nights. This rhythm surprised many researchers because natural comets usually show chaotic light changes, not steady cycles. Citizen scientists helped keep the world informed even when official data was delayed or missing. Their work proved that curiosity would not stop just because one major agency had gone silent. International teams also exchanged information privately, allowing research to continue without interruption. Each new update brought more questions, because none of the evidence completely matched the behavior of a standard comet, yet none fully explained the unusual physics behind 3I Atlas. This mix of clues and missing data made people wonder what NASA had really seen in the images that disappeared. And with the closest approach coming soon, one final question now rises above everything else. What will the world discover when Atlas moves close enough that nothing can hide it anymore? 3I Atlas has broken almost every rule that defines a natural comet, from its reverse tail and geometric jets to its controlled motion, strange chemistry, and survival through a violent solar storm. Each stage has revealed an object that behaves with purpose rather than chance. As 3I Atlas gets closer, everyone hopes to get clearer images and discover more interesting things about this interstellar object.